large scale of renewable energy business domestically and globally. So, without further more, I would welcome Dato Engineer Guntong Tobing. Please, Dato. Thank you.
Auto ni mas? You are muted by host. Okay, by host. Hello, can you hear me? Hello, Jeffrey.
Yes, I can hear.
Thank you. Thank you very much, Jeffrey. Thank you, Lily.
Thank you, Dato. Thank you.
Good afternoon. Selamat siang. Mangalaba. Hi, everyone. My name is Datuk Guntur. I'm from Malaysia. How are you doing, everyone?
Good, good, good.
Okay. How is your business in MCO or circuit breaker? How was the COVID-19 affect your business?
COVID-19. Same bad.
Yeah. You know, some of my friends who are close to me, they have to close shop because of the COVID-19.
Okay.
Some has to retrench their workers. Some do a pay cut among their staff. Most of my SME friends said their cash reserve are very little. They can only survive for 2 months. After that, they don't know what's going to happen to them.
Yep.
But I am lucky because my business is in solar and I'm not affected by COVID-19. During the pandemic, more people use electricity at their home and the electricity demand surged very high. So customers want to install a lot of solar panel to reduce the electricity bill. We have a total, in the beginning of the COVID-19, we have a total lockdown in the country, in Malaysia, since April. So when there is total lockdown, there was about 40% shortage of electricity demand by the utility companies. So that has really bring down. Normally we have 18 gigawatt hour, but in April we only had 11 gigawatt hour. So that was a real shutdown. And the power generation company does not expect to have this. But since there is a solar farm that generates electricity into the grid, so the energy from solar will have to be used first before the energy from other type of fuel. So let's talk about energy, solar energy business today. Is everybody from Myanmar? Can we switch on the slide, Lily?
Dato, you can share the screen in your computer.
Share the screen. I have to press the share screen. Huh?
Yeah, you need to share the screen, then you can directly control your slide. Thank you.
Wait. Sorry. Oh. I see. Baik. Okay. So how to turn on? Okay. So everyone, hi, I'm Guntur again. I am a solar PV company. We create solar farm. We do solar for residential rooftop, industrial rooftop, as well as utility scale solar farm. This is our solar farm in Malacca. The first one we complete in 2011, in 2014. And my company in Malaysia, we have 27 years of experience. We have 300 million ringgit worth of asset. We have a revenue of 760 million over the next 21 years. in Malaysia, the solar market is growing very rapidly, and the minister just announced a 1,000 megawatt quota license to be given away in the open bidding process in Malaysia. So yesterday, I have also have a webinar with the Minister of MOEE, Myanmar, also offering a 1,000 megawatt capacity. So the whole world is moving towards green, and I think this is a very coincidence. What a coincidence today that we have this session. We can share our experience, and who knows, maybe you can venture into this business. So in 2014, we completed the world's most efficient solar farm. When everybody take 5 acres to do 1 megawatt, our solar farm in Malacca only take 1.5 acres for 1 megawatt. And we do 20% yield higher than what we designed. In 2018, we completed the Malaysia first large-scale solar, 30 megawatt AC, connected to the grid on 8 November. After that, only other companies start connecting to the grid. So when you talk about solar photovoltaic, the most important aspect that you must consider is the irradiance. We are very fortunate that in ASEAN, we have a high irradiance. If you look at this irradiance data for Indonesia, in the Surabaya, you have a highest irradiance of 1534. And if you move into Indochina, we have Thailand, area in Nakhon, you have high, area in up south, we have higher, whereas area in the down north, you have slightly lower irradiance. Same as Vietnam. If you look at Vietnam irradiance data, you have high irradiance in Ho Chi Minh City area, but in Hanoi, it was slightly lower. So a lot of investors are moving into Ho Chi Minh City solar park in order to bid for a license. And for Myanmar, I can see very clear here that the highest irradiance of 1,600 kilowatt hour per kilowatt peak per year is in the area of central area like Mandalay, Napitau, Yangon is not so bad, but the further north, down north is not so good. Yeah. So Myanmar is a very good country to have solar, large scale solar, and you can provide this solar to the whole country. Kuala Lumpur in Malaysia, you can see that the northern part of the peninsular Malaysia on the left hand side, we have Kuala Lumpur. That is where the highest irradiance are. And the southern part near Singapore is less. And on the East Malaysia, you have the Sabah, Kota Kinabalu is highest irradiance, and the down in Kuching is lower irradiance. So ladies and gentlemen, friends and colleagues, solar is a very straightforward system. You have solar PV, solar panel. You have solar panel with solar cell. The moment you have sunlight photon strike into solar cell, you will generate DC current electricity. Then the electricity will go into a grid inverter. The grid inverter will convert from direct current to AC current and go to PV meter, and then you can use straight away. In Malaysia, our utility company is Tenaga Nasional Berhad. So that's principle how it works. So from a simple system at home where we install on the rooftop, then I take you to the next level where on the right hand side, I have circuit where we do a medium voltage installation. We do connection to, sorry, on the left hand side, we have medium voltage installation of 33 kilovolt kV system. We have an 8 megawatt solar farm. From the bottom, it goes to the up. If you read the circuit diagram, from the bottom, you go to the up, and from there, you can connect to the distribution line and sell the energy to the utility company. And on the right-hand side, we have a 132 kV. In the 132 kV, you will have to construct a switching station where you step up from 133 kV system into 132 kV, and you connect to the national grid. And as you know, we have ASEAN grid. So in the ASEAN grid connectivity system, we can generate electricity in Malaysia and export the energy to other parts of ASEAN like Thailand, Laos, Myanmar, Vietnam, and so on. So the significance of this project is in 2012, when we construct our plant, 8 megawatt plant system, we use 29,000 pieces of solar panel. But when we do in 2017, we only use 110,000 panel. And in terms of inverter selection, in 2012, we use a string inverter for 8 megawatt plant, where we need 390 pieces. But in 2017, we only use 14 units. You know, in 2012, when we start using the first one, and we have to use 390 pieces of string inverter, everybody laugh at us because they say, you are crazy, Guntur. You have to maintain and service 390 pieces and so much to do. But over time, people come back and say that was a very wise move. You know why? Because if we use string inverter in 2012, when the system breaks down, you have to bring in experts from Germany, from Sweden, from overseas to come and repair. And normally these parts will come and arrive you in 2 months or so. Whereas when we use string inverter, we buy a lot of spares. So we just use a junior technician to swap and replace whenever there is faulty unit. We replace the system. As a result of that, we have zero downtime, no outage in the 8 megawatt plant. When we have enough knowledge, expertise, we have our own in-house technician, then only we start using the central inverter. That's why in 2017, we are more confident. We use a string inverter over there. And in terms of employment opportunity, when we do 8 megawatt, we employ 230 people. And when we do the 37 megawatt, we have 304 people, employment opportunity working for us. And land size, as I explained to you, in 2012, we use 17 acre, about 1.5 acre per megawatt. But when we do the large-scale solar farm system, we need 98 acres of land. 84 million in 2012 and 214 million in 2017. Yeah. So in terms of timeline, when you talk about solar, large-scale solar farm, time is of essence. In Malacca, we take about 3 years to complete an 8 megawatt plant. When we do a 330 megawatt plant, we only need 1.5 years. So this means that the time that you need to do the construction has been reduced by half. So we have saved 50% of the cost that we need to spend on the overhead over the period of time. And we can start selling the energy within a short period of time, so the interest rate that we pay to the bank also is reduced. So this is an image of how the land looks like when we do the 8 megawatt plant. Before we start doing the construction, it was a bare land. There's nothing there. Then we start doing the construction. We put in the system. We do the earthwork clearing. We put in the fence, the cordon, and we put up the mounting structure. We install the solar panel. We put the control building, and we install and commission. And we're very happy to say that in Malacca, we have 100% local talent. So we are very honored and very grateful because the government of Malaysia do a lot of capacity building training in Malaysia in order for us to produce able and capable technicians to do the installation and repair of our solar power plant. And on the right hand side, when it's complete, it looks so nice. So that's where we won the award for the world most efficient solar farm by the European PV magazine. So as I told you, the most important aspect of solar PV plant is actually the irradiance. I share with you, Malacca is located in the southern part of Peninsular Malaysia. I only have 1,371 kilowatt hour per kilowatt peak per year. And Bido is a more north part of Malaysia. We have 1,472. So this is slightly higher. You see the difference, yeah? And in terms of generation, we are very fortunate. I put there in the Malacca plant, I put there the generation for the last 5 years, 6 years, and the dotted line. The dotted line is where we need to pay the bank loan. We need to produce 621,000 megawatt hour per month per year in order for us to pay the loan to the bank. So with this guideline, then we always observe to make sure that the project is always viable and the bankers are happy to receive their payment on time. There is also, if you notice, in 2016, the curve in 2016 is a bit lower than the rest of the curve because in 2016 we have a haze phenomena. Haze phenomena is a very serious issue where there is little sunlight that pass through from the sky to the terrestrial. So in that sense, it reduced our generation income by about 20%. And there is also in 2017 where we have eclipse. Eclipse means you have such a high irradiance and it creates drought in some of the agriculture area. However, in solar business, that was very good. That is the year when we achieved the highest revenue of all the time. So I now go to the generation from 30 megawatt solar farm in Bido. Bido plant is more steady because in Melaka, we talk about 8 megawatt DC capacity, whereas in Bido, we talk about 30 megawatt AC capacity. So when you convert from AC to DC, it is about 1.25 or 1.4, depending on the distance as well as the irradiance of the area. So in this case, we only use a conversion rate of 1.2 factor from DC to AC. So we are able to pay the bank loan. You see in November histogram, although you see the low, but November we start selling on the 8th of November, we start selling to the grid and we receive payment in the form of test energy before we start receive payment in the full rate of tariff. Then in 2020, in 2019, we have full year, but I don't have a data to share with you, but I'll share you maybe in the next session. So the other important aspect of solar energy is that people thought if you put up solar farm, you can get rich and you don't have to do anything. But in actual fact, you have to do the maintenance regularly, because the characteristic of solar panel is that you have annual degradation. Although the manufacturer put in data sheet the annual degradation is only 0.6% per year, but from our observation, we see degradation of about 13.75%. So with this degradation, it shows that we have to do some investigation and some repair work we have to do very aggressively. We send a module to the lab in Singapore as well as our own university collaboration lab. We discover that some of our solar panels have been affected by a phenomena called power-induced degradation. So power-induced degradation, PIC, you can fix the problem by putting a reverse current, or you can replace the whole module. Yeah. So the benefit of solar farm is that number one, we do create 230 highly skilled jobs. We train them, we give them high skill, we pay them high salary. Number two, spin-off business of about 254 million because you engage subcontractor. We give our contract to main contractor give to subcontractor give to another subcontractor, and subcontractor employ people to work. So that's where the spin-off of the company. And the carbon emission reduction is about 136,000 tons, and we support the ASEAN or the government program in reducing carbon emission reduction in the country. So the economic impact of this investment is total investment of 84 million. We have 203 ton carbon emission reduction for Melaka and 760 million ton for Bido. It's so much, 100% per year. But the most important of all this, government also make money from our project. We pay GST and we also pay government corporate tax. So from a barren land, we invest our money, 240 million to make up a solar farm. So this investment create a lot of employment opportunity for unemployed graduates, as well as those contractors who have no job. At the same time, we also pay tax to the government and to the local government. These are some of our staff that works. These are the vendor development program that we do. So normally people ask, oh, what kind of business can we create from solar farm project? Well, number one, O&M contract, F&B. We provide meal for our staff, landscape and nursery. Yeah, we don't have fuel, but we still have to cut the grass. Industrial training, a lot of students come and do internship with us. We have R&D partnership with universities. We have university from UK, university from Singapore, university from Malaysia, and we open. Now we are trying to do some MOU with university from Indonesia. We try to bring them in and let's share the knowledge together. And EPC contractor. Now, this is a very important slide. If you can see here, in 2011, in 2014, when we complete our project of 8 megawatt, it costs us about 5.7 million per megawatt, 10.5 million per megawatt. But then when we do the project in 2019, 18, when we complete the project, the price has dropped from 10 million to only 5.7 million. So it means to say that solar price are going down, and I was made to understand it is even further down at the moment currently. So it is now more competitive and it is a grid parity situation. So challenges that we face in this project, number one, financial. It's very difficult to get a bank loan. But after we do the first project complete and we have a good track record, now a lot of banks come and offer us the loan. Risk perception, normally bankers are not familiar with the risk of solar farm. They always ask us to change business to become a cafe, cyber cafe operator and so on. But we say, no, this is the business. And after the system performs, then they want to finance more project for us. And the third one is time of the essence. In doing solar project, the power purchase agreement is very important to do it on time. Because if you're late, then you'll be penalized, a big handsome penalized that we do. So ladies and gentlemen, I will now move into another area. We call it net energy metering. So net energy metering is also a solar, but just now we talk about megawatt capacity. Now with net energy metering, we just put solar on the rooftop. We use some of the energy. Whatever extra, we sell it back to the grid. So there are two types of package to purchase solar energy. Number one, you outright purchase, meaning that you buy the system from a system integrator like me, or there are a lot of other system integrator. So you pay a complete investment upfront. You enjoy full benefit of the saving from solar, and people like us, we provide operation and maintenance service. The other concept that you can buy the energy is you don't want to do no upfront cost to consumer. SI like Gading Kencana, we bear all the investment costs. We just signed a solar power purchase agreement privately for a tenure of 25 years to purchase the energy from solar PV. So the consumer only pay solar energy at the lower tariff than what the utility is charging. Why install solar PV for this in this method? Number one, energy bill saving. So the cost of solar energy is cheaper than cost for utility. Number two, you hedge the value of solar energy. So you know that the costs are increasing. The conventional energy costs are increasing every time. Like in 2019, Myanmar increased their tariff by about 20% electricity. So if you have a solar panel providing you energy, so you are guaranteed that your solar panel, God doesn't charge you extra for the irradiance of sunlight that they give to you. Number three is to reduce carbon footprint. Of course, today there are a lot of international companies, they call it RE100 company, who would like to buy the REC, the Renewable Energy Certificate, in order to make their product more green or more environmental friendly. So how does solar energy flows? How does solar energy flows? With utility power supply. As you can see in the diagram, number one, self-consumption of electricity generated by solar photovoltaic system user. Number two, we export any excess of energy to the grid as a credit and will be used to offset the total electricity bill on similar tariff basis. Number three, the energy export credit will be valid for 2 years. So whatever energy you generate from the roof, from the sun, will go down into your distribution board and used in the factory or offices. Whatever extra, say that day the irradiance is so good, your energy is high and your consumption maybe on Sunday or maybe on Christmas holiday. So the energy that is generated by the solar, instead of used by you because you are on holiday, you can export the energy to the grid. So tomorrow, when you come back to work, you use the energy. In case you don't have enough energy, then the energy will be used from your export energy to offset the bill from the utility. So project work scope and budgetary proposal. So in terms of net energy metering, you can put up a solar panel. You see in Malaysia, normally institutions like schools, they don't allow you to put on the rooftop because they're scared that your roof solar panel will break the roof and it will hurt the children. So what we did, we make an turn it into a car park system, car park rooftop. So you have a solar energy, and you also create a car park shade for the teachers and students to park their car, and you can collect some money from them if you want to charge them some money. Then the solar energy from solar panel, we go to the inverter, and then from inverter it goes to switchboard, and it go to household load. Whatever excess energy, it go to the TMB, it go into the outside utility substation. So before you do that, you need to do the 4 things. Number 1, you have to do feasibility study and budgetary cost. Number 2, we do design and supply commissioning of solar panel. Number 3, interconnection of solar. Number 4, registration. So you have to register with utility so that the utility company know that your factory or your building have a solar generating equipment. In case of any blackout or shutdown, then they know that there is electricity generating from the area, then we can take a safety precaution. So these are one of our projects. We have done many projects. This is one of our factory clients. So instead of after installing on the rooftop, they also make a big car park, and the energy generated from car park reduce their electricity bill by up to 20%. So tariff. In net energy metering, tariff is so very important. In Malaysia, there are a few tariffs for industry. For instance, tariff D, tariff E, tariff E1, E2, and tariff B, low voltage commercial. I shall share with you example of how does the net energy metering help save the electricity for you. Example number 1, if a customer have a E1 tariff, he is using, they are using E1 tariff. So if you look at the blue column, TMB only, on average, if you use only TMB, the total energy consumption is about 12 million kilowatt hour per month. And every month, their bill is about 5 million ringgit. So 5 million ringgit, you multiply by, you divide by 4.2, about 1 million US dollar. So if you put in solar panel, you see, solar panel does not reduce your energy consumption. Solar panel provide the same energy for your load. If your motor is using 1,000 kilowatt hour per month, electricity will supply 1,000 kilowatt hour. Solar also will supply 1,000 kilowatt hour. But the difference is, look at the green column. If you buy from TMB, utility company, say your solar panel, you can do 1,000 kilowatt hour per month, and you only buy from utility 11 million kilowatt hour. So in that sense, the difference is if you use total utility bill, you pay 5 million ringgit. But if you use the combine of solar and utility, you pay 4.2 million ringgit. So in that sense, you save about 19% of your bill. So one more thing, ladies and gentlemen, I want to share. In Malaysia, we have a regulation which say that you cannot install more than 100% of your load. You can only install up to 70% of your load. That is why my calculation is based on the regulation in Malaysia. Maybe in Myanmar, you have separate regulation. In Indonesia, you have separate, but it is almost the same concept. So that was the calculation for tariff E1. For tariff E2, the rates are lower. If you look at tariff E1, the tariff is 33 cents on energy and solar we charge only 30 cents. Yeah. And in the E2 tariff, your peak is 35 cents, and your off-peak period is only about 21 cents. So there are two categories of tariff. So again, here in my calculation, I have the blue column. We say if you use utility only, your bill it will be 3.9 million a month. But if you use combined, you can achieve 3.5 million. So here, although you see the saving is smaller, only 3%, but the magnitude of 3% is close to million ringgit. Yeah, just now you see big saving, but the big percentage, but the saving number is small. So in this case, you see small percentage, but the magnitude number is higher. So that's how the system works. Yeah? And of course, the most interesting one is the tariff D consumer. Tariff D consumer, the fixed tariff is 38 cents, and more than 200 kilowatt hour, you pay 44 cents. And solar, you sell at maximum of 30 cents all year through. So in this category, if you calculate the saving, you use TMB only, your bill will be 1.4 million. If you use the TMB, if you use the utility and the solar, your bill is 1.1 million. So there is a saving of about 17%. So you see the saving calculation over there. So as I told you, in the net energy metering, this one is my client, Daikin Malaysia. We put a 1 megawatt system, energy yield per system about 1.3 million kilowatt hour per year. So carbon emission reduction about 26,000 ton per annum. So the other important aspect in the rooftop system is normally people will be scared that your installation may create some kind of leaking on the system. So this is another important area when you do you decide an installation. Number one, bracket for the roof tile. So you make sure you don't knock anything and dig a hole on the tile. So you use a bracket where you can slip through the jacket. And the aluminum rail screw on the bracket. So meaning that you don't touch the solar. And then you have bracket metal type where you can clamp on the tiles. And from there you have shingle, and it can work as a supporter, a very strong supporter. So these are the type of installation. We have solar array, we suit various installation. We also install one in our capital in Putrajaya. So if you have like number one, 2 kilowatt system, this is the roof where we put in the aluminum runner in Selangor. And then the other system we put in TT Ajaya, the other different orientation. If you have a two orientation solar panel, we put in there on residential in Bangi, and 12 kilowatt system. So there are various types of system, but these are all the roof, the normal roof, either V-shape or A-shape roof. But they are also, see, like this. This picture is while we do the installation, we make sure all the cable are tested before we do the connection, because we want to make sure that all module that we install are good and it can work during the time. So before we do the connection, we test the system. We check the IV curve first before it is being connected on the roof. So this is another client. We have a roof. The roof is flat like that. So what we do is that we create a shape, a structure, so that you have a 7 degrees tilt angle facing south in order to get the highest irradiance from the sun. So this another side. This guy has got aluminium metal deck. So for aluminium metal deck is more serious and more dangerous. We make sure we don't have any holes, because once it leaks, you're going to have a lot of problems to troubleshoot the leaking, as well as to fix it, and you have to remove the solar. You have to. That's why experience and expertise in doing the installation is very important to ensure a good quality system installed. So this is another one, again on rooftop. This is a common problem in any metal deck roof installation, because if they're not careful, you're going to crack. You are going to have a nightmare because of the leaking, and it's not easy to troubleshoot, to identify, to locate where does the leak come from. Yeah. So in our project, besides doing EPC, besides doing consultancy, we also identify a few more projects. At the moment, we are trying to invest in the floating solar in Malaysia. In Malaysia, we have also a lot of lake where, as you know, Malaysia was formerly known as a tin mining country, one of the largest tin mine country in the world. So there are about 1,900 ex-mining ponds. So we are identifying a few for us to do floating solar farm. In this way, we will save the soil, the land, for them to use as a cultivation for agriculture product. And as we use the ex-mining pond, which is no value, barren land, we can use this one for mining. We are also working with our housing community housing board, where house is always expensive to build, and for the community to afford to buy a house is expensive. So what we do is that we want to develop a housing scheme with solar roof, and we take the revenue from solar. When we sell the energy, we make some money. The money from energy we will use to defray the loan repayment, part of the loan repayment for the housing that they pay. So in this way, it will make the house affordable, and the bank cannot deny the application from the home buyer, because they are guaranteed payment from the energy bill, energy income coming from the utility company. So this is another example project. We have aquaculture center. Instead of leave the roof like normal roof, we make it into a solar farm, generate electricity, use it there, and export to the grid, whatever excess. And a futsal court, we put in like this also. So you have both. You can pay the rental of the land from the income from futsal as well as income from solar. So as I explained just now, we also make a lot of car park roof so that it can be used in church, in mosque, in religious worship place. You can use this system. All right. So that is about some of my sharing experience in solar project with you guys. If you have any question, I will be happy to answer. Thank you very much, Jeffrey.
Oh, jam 3 keburu nggak ya? Ini baru mau jalan nih kita dari Glodok. Oh, baru mau sih.
Hi, Dato'. We have a question here from Mr. Kenji Liao. It's on the chat box. He asks, what type of irradiance sensor used? What is the specification? Please elaborate further on power induced on PV panel performance degradation. What are the types of reverse current method used and any hardware involved? The question posed is very long, but it's in the chat itself. Are you able to see this? I will put it on the chat box as well while we are waiting for Jeffrey to come back. Thank you.
Can you repeat the question again, Lily?
The question is, what type of irradiance sensor used? What is the specification?
Okay.
Please elaborate further on power induced on PV panel performance degradation.
Okay.
What are the types of reverse current method used and any hardware involved?
Okay.
How do we validate the conversion loss from DC to AC?
Okay.
What are the measuring devices is needed? Oh, Kenji, your question is very long. Actually, we have about like 20 questions queuing up for Dato' as well.
Okay, I'll answer one part. What is power-induced degradation? The rest we can respond from email.
Yes, yes.
Power-induced degradation is is a default on the cell when you laminate the cell during the production. There was certain element that need to be done. So today, power-induced degradation, after observing this problem in the market, a lot of manufacturers are using PERT technology. PERT technology is a process where they laminate with another N-type. You have a P-type, N-type. So the N-type cells are being covered so that the PID effect will not happen anymore. So of late, I don't see this PID impact more severe than what we experienced in Melaka. Our new plant, we have PERT technology. That's why when we bought last time, we either choose monocrystalline or polycrystalline. PID happen most of the time on the monocrystalline module, but the polycrystalline, you also have this experience. As for the conversion, there are a very complex calculation formula to use. When we do a power system study, from the power system study, we'll show you what is the level, what is the fault current level of the grid that you need to cover. If you cannot compensate with your solar conversion, then you have to compensate with a capacitor bank. So in our case, we do both. 1 megawatt solar cost me at that time about 3 million ringgit. And 1 megawatt capacitor cost me only 700,000 ringgit. But 1 megawatt solar, although it's expensive, can generate income for me. But 1 megawatt capacitor bank cannot generate income for me. So that's where you have to make a business judgment. I will cover for you the rest. Can I have another question, Lily?
Yes, Dato.
Yep.
I'm back. Sorry. Okay, this one come from Mr. Pia Pyongpan from Myanmar. What are the benefits of the urban organic waste recycling in developing nations, and what are the challenges it faces? And how can we improve the system and get more benefits from organic waste recycling?
Organic waste.
Yes, organic waste recycling.
Recycling.
Is more about the energy. Yeah. Maybe.
Well, electronic waste. Do you consider electronic waste as organic waste? Today, people buy electronic waste. We do, last time, when we want to throw our solar panel, we pay people to collect our solar panel, electronic waste. Today, people come and pay us to get our electronic waste.
Okay.
Because there are some gold content, there are some aluminium on the frame, there are a lot of things that do. And there are even some manufacturers who buy back, you know, like First Solar, they guarantee they buy back the module. I think that is a very relevant question, because if you have 100 acres of solar panel on the ground, after 21 years, when the power purchase agreement expires, what are you going to do with so many cells? But that was one of the worry when we started the plant in Melaka in 2012. But today, instead of we asking people to buy and pay people to destroy, pay people to dispose for us, people come to our plant and start buying from us. So because they said there is some monetary value to the waste, the waste, and they can recycle, they can resell, and they can make some money, and everybody is happy. At least I am very happy to know that people recycle my solar module, because I was thinking of sending this used solar module with less efficiency to rural area where you can use it as a street lighting, you can use a solar home system. Well, it is less, but you don't require such high efficiency like our power plant. As long as the solar can generate electricity, you can put energy in the battery and you can use it at night. That's all. So instead of giving 1 kilowatt, you can give 10 kilowatt solar panel for free. You have used all the value for now. But today, this is a better solution for us, because people come and buy. We can eliminate the storage problem. We can eliminate the transportation problem. People just come and buy and recycle it for the use. Yeah.
Okay. That's good. Good. Okay. We jump to another question.
Okay.
This from the Myanmar side, also from Mr. Ted Mao Chow. So I have a pig farm how can I produce biogas? I have about 1,000 over pigs. I want to expand to a chicken farm too. So what kind of investment are we looking at?
Okay, this is a question on biogas.
Yep.
Yes, we have some experience in biogas. In Malaysia, 1 megawatt biogas is about 8 million ringgit. So 8 million ringgit, if you divide by 4.3, it's about 1.8 million US dollar for 1 megawatt. So chicken farm, the manure, the pig manure. I went to Germany and see the pig farm. That's how they use with the pig with the chicken manure as well as the pig manure. So it is a viable project. The generation, the biogas is, I think, more sustainable than the solar, because solar only work during daytime, whereas the biogas can work 24 hours. So you store, if you have 1,000 pig in your farm, that would be good, but I think you have to increase some more the number in order for you to collect enough manure and turn it into a gas chamber and use it as to generate electricity. That's a very good question. Set.
Yep. Thank you. So jump to third question. This is from Mr. Zaulat from Myanmar. So should a small island state choose a plasma gasification waste to energy plant or solar farm?
Again, plasma?
Yes, should a small island state choose a plasma gasification waste to energy plant or using a solar farm? So maybe he asked, is it using a plasma gasification waste or a solar farm?
The best thing is to hybrid both technology, because plasma gasification waste to energy is a very good technology. We have seen some system work very well and some system does not work that well. So if you have a hybrid system between solar and gasification, plasma gasification, so when you have, whereas solar can generate electricity daytime, yeah, it is not a rocket science anymore to make solar system work. But for plasma gasification, there are a lot of nitty-gritty issues that you have to address. A plasma gasification does not work because the kind of waste that we have are very humid, a lot of water content, and some of these plasma gasification cannot absorb too many moisture and too many water content of the waste. So while managing both sides, before you acquire equilibrium or acquire the correct knowledge to make sure the plasma gasification can work without any interruption, so you also have solar panel, solar energy to support you along the way. So in that sense, I think a hybrid system would be good. But you don't have enough, if you don't have enough money, because solar, if you invest in solar, it is a straightforward system. People, you don't have to come up with a capex because other third party may come invest in system and sell the energy. But if you go for plasma gasification, normally gasification developer will ask for tipping charges. Tipping charges means instead of taking the waste for free, they are charging the local authority. If you want to throw your waste to me for me to make energy, you pay me a certain amount of money for 1 ton or what, in order for them to make the cash flow works. Otherwise, it cannot work. But if the budget is sponsored by government, then it's a different story. Nowadays, we are moving towards a private sector-driven economy. So in a private sector-driven economy, it has to be self-sustaining and self-financing. So in that sense, I think solar is more financially viable and more, it's already acceptable investment in the world where anybody can come in, invest money and put out the system.
Okay, thank you. So another question. This is from Mr. Somwang Nantaripsu. So for your LSS project, Badr, How many houses or factory can it power?
For the energy we generate from the LSS, it can power up to 200,000 houses. We generate 53 million kilowatt hour per year. If we generate 53 million kilowatt hour per year, and if one house consume about 3 kilowatt hour per day, or 5 kilowatt hour per day, then you will have about 10,000 house that we do every day. So you can power a whole township with this kind of capacity. But now we are moving from 30 megawatt because we want to bring down the cost. Yeah? The cost that, as you can see in my graph just now, in 2017, our rate was about 80 cent ringgit, about 20 cent US. In 2018, our rate is only 10 cent US. Today, we are talking about 5 cent US. Because I noticed here that in Myanmar, when you did a price hike in 2019, there is an increase in the domestic consumer. Before, it was about 15 cent US per kilowatt hour, but it was increased to, 0.15 US, increased to 0.99 US. And then for the non-domestic, the increase was from 0.44 to 51.2. This one is ringgit. So the increase is rather a lot, and it creates a lot of impact in the market. But I must confess with you, although you have this increase, but your tariff in Myanmar is still lower than what we pay in Malaysia. Next one, Jeffrey.
Oh, okay. Wow, it's very impressive. Okay, next. What is your take on solar panel and solar roof tiles? Which one is more effective for housing and factory?
Rooftop and roof tile. Huh?
Yeah, rooftop and roof tiles.
Okay. Thank you very much. This is a very good question. You know, I went to Shanghai, the SNEC, Shanghai New Energy Conference in 2009. The first time I went to Shanghai. There I saw a company producing solar roof tile. During that time already. But at that time, it was so expensive. I was hoping that the price can go down. And then when Elon Musk introduced the solar roof tile, very nice, very lovely, look exactly like a roof. That was also another good one, but everybody is still waiting. What is the price of that Elon Musk roof tile that it's going to cost? Nobody can give a cost. And I was made to understand that there's one factory in Malaysia belong to Panasonic. They said they are busy making solar heterojunction solar module with about 22% efficiency for this kind of project. So that is the thing. So in other words, it means that solar roof tile is the best because that is so natural, but the cost is so high that it's not able to bring down yet because there was no volume there was no mass production, mass demand on it. Whereas the solar, if you use solar panel as rooftop, solar panel, I think today there is at least about 17 gigawatt production capacity. In China, it's even much more. That's why the price can go down when you have such a big volume. The innovation, the automation, the volume demand, and so on. So that bring the price down. I hope one day the solar roof tile, can have that kind of volume to bring down the cost at the price that we are paying now. Because today, solar cell, if you buy the module, it costs what? 20 cents, 22 cents? Yeah, even the German are bringing down their price because they cannot sustain. And now under the present low tariff, if you see the bidding price in Abu Dhabi, in Dubai, they are much lower than what we pay, what our price in this region. Yeah. So of course, I would love to see a roof tile, but we have to wait until the price go down. As a rooftop, although it looks sometimes it doesn't just that well, but well, okay, still cheaper than utility price, still serve the purpose. I think we can live with the solar rooftop at the moment. And one day we hope the solar rooftop price can go down lower than the solar rooftop system.
Yeah. Wow. Good. So we have a question from Mrs. Sulai. Our beverage factory is installing a 50 kilowatt solar system, but how do I know that the installation is actually done proper? Is there a checklist, or what are the things should we look out for?
Yeah. Thank you, Mr. Sulai. It was a very good question. This is normally the issue that the consumer will face. Do I get the money that I pay for? Do I get the solar panel that the contractor install? Is that worth the money that I spent? Yeah. Of course, in solar panel, there are very stringent standard of SOP, standard of procedure. We have IEC standard which you can follow. In Malaysia, we have adopted the IEC standard into Malaysia standard. And if you need, of course, we can upload some of these standards you can follow as your checklist. Yes, there is a checklist for it. I think in Malaysia, we use IEC for, I can't remember the number, but I can share with you later, Mr. Sulai.
Okay.
Right.
Okay, we jump to another question. This is from Jin. How to minimize cable loss and system loss for your floating solar project compared to ground-mounted solar farm?
Oh, how to minimize cable loss?
Cable loss and system loss for your floating solar project compared to the ground-mounted solar farm.
Yeah. Okay, that is a very good question. Actually, solar, you know that efficiency of a performance ratio of any solar plant is about 85%. Efficiency of solar module is only about, in the market now, is about 18.5, but when you do the measurement, it's about 16.5, which is good enough. Yeah. Now, if the moment you do on a floating solar panel, yeah, floating solar panel, the efficiency of the solar generation increased by about 15% based on report that I received. There is a big research facility in Singapore. They do and they check. They confirm that the generation efficiency of the module increased by about 10 to 15% if you do a floating solar farm. The current, the cable type, the floater that you use, these are the other issue that you have to take into consideration. There are ways and means to do the calculation. You want to reduce the loss, you design a thicker cable. You buy a lower loss cable from manufacturers in Switzerland, in whatever. There are also a company in China who produce low loss cable and so forth. But if you want to know how do you minimize the cost, how do you minimize the loss, you have to weigh the two, the loss and the increase in cable cost. Yeah, but cable cost is very important. You cannot afford to buy a cheap one and reduce your capex, but in the end, over the long run, you lose in terms of power generation and cable loss, because solar energy is a very expensive energy to generate. So if you generate, you make sure you want to reduce the loss along the way, all the way, along the way and all the way. The difference between solar floating and ground mount is that floating solar costs about 6% more than the ground mount solar. Floating solar gives you 15% higher efficiency compared to ground mount. So cable losses is all up to the designer who designed the cable and the developer who decide how much you want to put money. The difference of the two things is you put on the ground, you have to pay rental of the ground, which is normal rate. You put on the water, sometimes the water is free of charge. Yeah, nobody knows how to charge you based on water top, because you can still rear fish under your aquaculture, under your water.
Okay. So Pak, this is the last question.
Okay.
What if my solar system doesn't generate as much energy as anticipated? I have a plastic recycling factory that runs 24 hours a day. What is your suggestion?
Solar system does not generate enough.
If my solar system doesn't generate as much energy as anticipated. So he has a plastic recycling factory that runs 24 hours a day. So maybe you have the suggestion for him.
Normally, you have to go back to the consultant who designed the system for you.
Okay.
Sometimes the mismatch between the resistance, between the impedance at the module and at the inverter. Sometimes there are mismatch in terms of cable sizing. Sometimes there are module which has a higher degradation period. Remember, I showed you my graph just now. When I did the first plant in Malacca, I'm supposed to have a 0.6% degradation every year, but I have 13% degradation every year, and I have to manage that part. Yeah.
Yep.
So because I did my own design, I take my own responsibility and I fix it. I go after the manufacturer, although they say manufacturer from China are no good, but I see that they are very sincere, very honorable. They take responsibility, but it just takes some time because I don't speak good Mandarin. I don't speak good Mandarin. 我不会讲很好的华语. So that's why it's a bit it takes some time for them to understand what is the problem. They say we give you good system. Yeah, it was good system the first year. But 我不知道. So there was some like communication issue. That's number one. Number two is the consultant. If the designer who do the design for you, they have professional liability when they design. They have to explain to you what went wrong. And if you want to check whether your system is good or not, there are many methods to do it now. You can either use a drone when electroluminescent, you go on the top, you can detect which are the module which is already faulty. Sometimes when you don't have the experience to do the installation, your panel can be default when you do the installation. Maybe the installer are not familiar between the positive and negative thing, positive and negative probe. So they make some changes. So there is only one or two cell which is short circuit. So that can be a problem. So if your system has been installed for about 5 years or so, I suggest you do an audit. Get somebody who are qualified or who are doing a drone service. They can fly a drone. You can look at the image. Otherwise, you do manually. You have to go up your roof, check one by one, which take time, which is quite tedious work, can be costly. The drone are more cheaper, of course. Yeah, and faster.
Okay. So actually, it's a lot of questions.
Oh my God!
But we are running out of time. Maybe Lily, maybe can email to you later for all the questions.
Thank you, Pak Jeffrey.
Thank you, Pak. So I would like to thank everyone for this fruitful sharing today. I believe all the audience or the people learn a lot of this solar energy today from
Pak Jeffrey, can you ask any one of the audience, anybody is submitting a bid for the 1,000 megawatt solar farm announced by the Myanmar government?
Yeah, maybe Lily or can help.
Hi, Dato. We actually have some people from the ministry are watching this over at the Facebook now. We still have questions for you from the factory owner side. But yes, time is running out. But however, we will send this question to you, and we would like you to do some consultation, together with them as well.
We'll do it with you, Lily.
Yeah, we will pass this back to Lily. Thank you, Dato'. Thank you for your time.
Okay,
Thank you, Dato'. Thank you.
Yeah, maybe we can communicate later in Indonesia.
Yeah, I'm waiting for your project in Indonesia. We have a lot of sun and very hot here.
Of course. Thank you, Pak.
Thank you. So I'm passing to Lily. Thank you.
Thank you, Jeffrey, and thank you, Dato' untuk it is the nice and interesting knowledge sharing webinar. And I hope everyone have a nice sharing for the question on the chat box. And we will send them all to the expert and do this posting on our Facebook group at Knowledge for Action. So you can reach the expert themselves at their email too. And if you have a doubt, just send us a message. We will reply them over, especially for our Myanmar viewer. And this video can be viewed in our Facebook page and website, so you can continue your question posting. And now I will pass to Vishnu to address our Myanmar community in Burmese. Thank you.
Okay, alo mình. Okay, alo mình là ba. Hoặc đến đây cho tôi đây bọn nó, tụi nó đi expert đi hà của alo cho đông mình thêm mà đấy. Cái đó bọn nó mấy cũng nên xí luôn xem cho nó Facebook page đi. Đi live bên hà này hà này bây giờ cho nó mấy cũng này mấy anh đó rồi đấy. Cho nó đi nè expert đi của. Then I maybe đó translate lúc bị cô rồi Gmail nó xí yo. Cho nó then I biểu biểu về đó mà bé. Đi này đi qua ở bọn nó lại áp đặt cho lại lưu ra luôn của bé. Nát không bị lưu ra luôn của đấy. Cho nó đi nè đi tu thêm mà đấy. Thank you very much, everyone. Thank you for your time. We're going to end the session now. Thank you very much.